Hey everyone, welcome to my tutorial on how to assemble your Tektite-A kit. First off, we'll start with assembling the canards. So the first thing you're going to want to do is you'll notice that these holes have some 3D printed plastic in them. So you can just take your screws for the servo and you can put them in here and you can screw it in and that will clean it up. Now we will assemble the transition. So you need to first hook up all the wires. So you're going to start out with the battery. You simply just put the wires in. Make sure they're facing outwards. And you slide the battery into here. Now you need the wires to go to the right place. So this white charging cable goes to this spot next to the wall of the transition. So just use your fingers to push it there. And you're also going to need to take the power connector and put it into this hole that's further away from the wall of the transition. Make sure to just push the wires around until you can get it to go. In this case, you're going to want to compare it, the orientation of this connector to that of the flight computer. You can see you want the square end to be more up relative to the charging cable. Now just push it through and you have the battery installed. Next, check your flight computer. You should have 3 servo ports and your power connector soldered to the bottom, while the programming header and the power kit connector should be soldered to the top. For the servos, first put the cable in to the hole. Then pull the cable through such that you can put this lip of the servo into the corresponding hole in the transition. Now take the servo wire and put it through the servo wire hole. Do the same for the other servo. All right, so now we have everything installed inside the transition and we have all the cables coming out for the flight computer. Because we're done with this, you can put the transition together. Take the other half of the transition, line it up, and start pushing it in. You'll notice that it gets hard to push in around here. That's because you're going to want to take these little prongs and make sure they aren't pushing against anything. So over here, you can see that this one seems to be lined up, but this one, for example, is touching the servo housing. So I'll just move that over, and that went in. This one is interfering, so having these tight isn't critical to having a good fit, but it makes the assembly process a little difficult. So I wiggled this part around and now it managed to click in, so I can just put it together like that. Now you have a mostly completed flight computer assembly. Take your long, thin M2 screws, put them in the hole and use your small screwdriver to screw it in. Be very careful with this one because the threads are very small, and so if you screw it too much at the end, it'll break the threads. You don't need to tighten these super hard because the plastic will hold it pretty well. So just tighten it just enough that it's inside of the hole and seated inside of the little recessed area. Now I'll do the same for the other 4 screws. Okay, so now it's completely done. Your transition's together and you shouldn't be able to pull it apart. Next, we're gonna install the servo ports. So you'll see that they have this orange wire, a red wire, and a brown wire. The red and brown wires are power and ground, while the orange wire is signal. You can see that there's signal, power, and ground marked on the circuit board too. It says S plus minus. So make sure to line up the orange wire with the S on the circuit board. Like on this case, you can see S is on the left, so I keep the orange on my right. Keep the same orientation for the other servo. And now, that's installed. Push the cables into the housing. And install the power connector. Again, it'll only fit in one way, so just push it in. Finally, push all the cables into the housing. And eventually, it should just fit in. Okay. So now it's fit in. And you can see it's nice and flush with the top. You'll see you have these 4 small screws. However, don't be mistaken. If you're using a peanut altimeter, you're only going to install 2 of these screws into the flight computer. So you have to do the bottom left screw. And in this case, you might want a larger screwdriver. It'll still work fine with a smaller screwdriver, but it can feel nicer with the larger screwdriver since you're threading into the plastic. Do the corresponding diagonal screw. Now the peanut altimeter is going to go along this diagonal. So grab your altimeter and use the 2 included peanut altimeter mounting pins. You take these longer screws over here. You can see them compared to the short screws. Use this one. Put it through the hole. And mount it on here. You're gonna want this end to be as close to the servo connector as possible. Tighten it all the way so that it doesn't spin during the flight. So now it can resist me pushing on it. For this side, don't tighten this sides all the way. Make sure you can still spin it and to line up the holes for the peanut altimeter. You see the holes line up perfectly right now? So I will start screwing it in. This time you do use the small hole screws. See, it does want to turn. It's fine. Turn it back to where it's supposed to be. And install the other screw. Now, your peanut altimeter is mounted on top of your flight computer. All that's left now is our canards. Now that you've removed the flashing on them, you need to calibrate the servos. Alright, so now we're going to set up the servos and calibrate them. First, connect the flight computer to your computer via USB-C. Note that the cable is not included. So open up your rocket. If you don't have one, just name it after either your target altitude or just quals if you want to do it like that. Then press this big connect button. Right now you don't need to worry about any of these numbers. Just go to rocket configuration and you can see we have this servo port section. So if I move both of the servos to some place and I press test, it didn't move anything, which means that we probably don't have anything plugged into this servo port. So let's try the other port. You can see it moved that servo, right? Now, normally this comes at a default of 45. At this point, this piece should be a little left of where it is. Of vertical, I mean. So I'm gonna pull it out. So it should be a little left of vertical, but as close to vertical as you can get it. So I think this looks a little left of vertical, but pretty close to vertical. So I'll push it in. And now when we go to the maximum, which is normally at 105, we can see that it should be close to horizontal. This is good enough, at which point we can put the canard on, because we know it's roughly in the right area. So, first, put a screw in this screw hole, and while looking in the hole, put your screwdriver in and try to line up with this screw. Next, you can look from this side and you can just spin this screwdriver until you can see the screw come out. Once you see it lined up with the center, you can just spin it clockwise and you can see the screw coming out. Once it's flush with this part of the canard, you can put it onto the rocket and finish screwing it in. Feel free to tighten this as much as you want. Now you can see that we have a canard on the rocket. Now I'll do the same thing for the third servo port, since we're using that one too. So I'll go to the minimum position. And I'll take it out. You can turn it horizontal and take it out. Put the minimum position. And put it as close to vertical as you can while not making it past vertical. I think that this is a little too far, so I'll go one left of that. So that's this. Finally, I'll once again put it in the screw, put your screwdriver on, and do that. Screw it on, keep on going until it's tight, and we have this servo installed. Now that both of your servos are, whether your canards are installed, we can tune the servos. So you can see that when we go to S2 minimum, it says that the position of the canard should be vertical. So you can see this is slightly left of vertical. So I'll just keep on increasing it by 1 and hitting enter. You can see that 48 makes it look pretty vertical. You can see that there's sliver on the black of the left and sliver of black on the right. Let's do the same for the other side. So we'll go to S3 minimum. So that is a pretty far left. So if we go 46, 47, 48, 50, 51, 52 looks pretty much vertical. So now we'll do the horizontal position. So if we go to S2 maximum, we'll see the position of the canard should be horizontal. So when I click this, it looks like it's a little tilted like this. So I'll just make it a little lower. That looks a little too far. This looks pretty much horizontal to me. Let's do the same for the other side.
That doesn't look far enough.
That looks pretty much horizontal. So now you can see we've got both our canards in the horizontal positions. This is how much drag it would be creating at full drag. It's quite a bit of frontal surface area, as you can see. And we can just make them both vertical by testing the vertical position. Just like that, you've finished your Tektite-A flight computer kit. Feel free to tie parachutes onto the bottom for recovery. Thank you.